Hello. So we're going to do the integral of sine to the fourth of x. And the moves we're about to do are not that much different. I believe you've already done the integral of cosine squared or maybe sine squared, but either way, they're kind of exactly the same. So when you did that, you used a power reducing identity to write cosine squared as 1/2 1 plus cosine of 2x. So it's mostly trig identities in algebra. So we're going to do basically the same thing here. So here we go. So the first big move is to rewrite sine to the fourth as sine squared times sine squared. Nothing wrong with that, right? I can do that. And now you're just going to use those same power reducing identities. You're just going to have to use them twice. So that gives you integral of 1/2 1 minus cosine of 2x. It's okay if you don't remember these identities from trig. Nobody does. Times 1/2 1 minus cosine of 2x. And now, as you can see, it's just kind of a lot of algebra. So let's go with the algebra. All right. I'm going to take the 1/2 and the 1/2 and multiply them and bring them out front as a constant of 1/4. And then I'm going to take 1 minus cosine of 2x and just FOIL it with itself. So it's going to be 1 minus 2 cosine of 2x plus cosine squared of 2x. You know how to integrate that. I hope. You know how to integrate that. This is going to take a little bit of doing. So again, it's not that clever. We're literally just going to use the same power reducing identities again on that. But now it's cosine squared of 2x. So we have to do a little bit of stuff with that. So here's the identity. I'm going to use the variable u. Cosine squared of u is 1/2 1 plus cosine of 2u. That seems like a mistake, but it's not. They both involve cosine. So if u is 2x, then by substitution, and not even calc style substitution, literally just sticking in 2x for u, you get cosine squared of 2x is 1/2 1 plus cosine of 2 times 2x, which is 4x. Okay, so that's just using the identity. That's not calculus or anything. That's just using the identity, except instead of the angle, you got double the angle. So it's almost like a double angle identity. Okay, so that's going to go in there. Notice we haven't done any calculus yet, right? This is all just trig identities in algebra. So it's integral of 1 minus 2 cosine of 2x plus all this 1/2 1 plus cosine of 4x. How many parentheses do I need? Too many. And then I think I'm just going to let you take it from here. This is going to distribute out, so you're going to have a 1/2 plus 1/2 cosine of 4x. The 1/2 is going to combine with the 1. Your answer is going to have some like 1/8 and I think even some 1/32 in it. So because of these angles, you're going to have to do little mini u subs where a 1/4 comes out front and stuff. And then obviously just check your answer. Just, you can literally Google integral of sine to the fourth. Okay, so that's the trick. With these, the integration is the easy part, right? As we're saying, it's all the trig stuff that comes before it that you gotta kind of figure out. So the moves we just did would be exactly the same as if I asked you to do the integral of cosine to the fourth instead. Exactly the same thing. You just use the power reducing identity for cosine. It'd be exactly the same kind of moves if I asked you to do the integral of sine squared times cosine squared. You just use both at the same time, FOIL everything out. Believe it or not, it would be exactly the same as if I asked you to do the integral of sine to the 6th of x. Now, I wouldn't do that because it would take forever, but that is how you get that integral. You just call that sine squared times sine squared times sine squared, multiply everything out, right? So in the next unit, we get formulas that let us like not actually do that. But you'll see it is the same technique, or, sine to the 8th of x or cosine to the 24th of x or whatever. Not doing it, but theoretically it could be done, and it could be done the same way. Okay, so that's how you do sine to the 4th. Thank you.